Modern architecture scales by adding compute, creating structural friction. As teams spin up individual workspaces, the underlying data environments fracture into isolated silos. This fragmentation stems from the legacy standard for metadata management, the Hadoop-era Hive Metastore. Because it is bound to a single workspace, Databricks officially classifies the workspace local Hive Metastore as a deprecated pattern. Looking at the Databricks reference architecture, Unity Catalog sits directly between the compute and storage layers. This account-level positioning unifies tabular data, unstructured files, and ML models under a single security model, applied uniformly across all workspaces. Decoupling access control from the workspace allows permissions to remain consistent even as the number of compute environments grows. The legacy Hive Metastore organizes data using a two-level namespace, schema, then table. Because there is no higher organizing tier, that structure is trapped entirely inside a single workspace. Unity Catalog solves this by introducing a three-level namespace: catalog, schema, and object. Within this new hierarchy, objects are classified as either managed or external assets. For managed assets, Unity Catalog handles both the governance rules and the lifecycle of the underlying file storage. For external assets, it handles governance only, pointing to data stored in your existing cloud buckets. Adding the catalog level at the top of the namespace is the mechanical change that allows a centralized system to project security policies downward across multiple workspaces. This centralized structure replaces brittle table-by-table access control lists with attribute-based access control, or ABAC. ABAC relies on centralized governed tags, such as labeling a specific schema as PII. Once a tag is applied, the system automatically projects the associated security policies across the entire catalog. These policies enforce security using row filters. These SQL user-defined functions evaluate every row at query time, excluding unauthorized data. Similarly, column masks obscure specific values within a single column, redacting sensitive data, while leaving the rest of the row intact. Tying UDFs directly to governed tags separates the responsibility of security policy creation from the daily tasks of data stewards, enforcing rules automatically as new tables are tagged. However, these functions introduce a mechanical tension. Complex UDFs block the SQL compiler from utilizing predicate pushdown, impacting query performance. When faced with this conflict, the query optimizer follows a primary directive. It will always choose preventing information leakage over maximizing query speed. To mitigate this performance impact, engineers must keep SQL UDFs simple and avoid nesting complex subqueries inside their security logic. There is also a risk regarding data type mismatches within a UDF. If a mismatch occurs, the system might silently convert values to null, breaking the underlying security logic and returning incorrect row data. This makes enforcing ANSI mode a technical requirement. Setting spark.sql.ansi.enable to true ensures that UDF errors raise an alert rather than silently compromising the table. As pipelines expand into multimodal AI, they increasingly rely on unstructured data, like images and PDFs. These formats cannot be governed by traditional table-based access controls. Unity Catalog volumes resolve this by bringing unstructured data under the same unified governance model as structured tables. But this presents a mechanical problem. External computing engines like Daft or Ray often lack native Databricks connectors. How do they read these volumes securely? The solution is an API credential vending flow. Instead of using static cloud IAM roles, the external engine queries the Unity Catalog REST API. Unity Catalog evaluates the user's permissions. If authorized, it issues a temporary, highly scoped cloud storage credential directly to the external engine. This API mechanism eliminates manual IAM credential sprawl, allowing external tools to process governed data without permanent keys. Alongside access control, Unity Catalog automatically captures data lineage for all queries run on the platform, tracking dependencies down to the specific column level. This lineage data is aggregated continuously across all workspaces attached to the Metastore. With this map of data flow, data engineers can perform precise impact analysis before altering a schema, and compliance teams can trace exactly where sensitive data originates and is consumed. A governance layer is logically incomplete without automated lineage to verify that security policies are actually reaching the correct downstream assets. The Unity Catalog architecture functions as a hub-and-spoke security model. It anchors the system so that decentralized engineering teams can operate with a shared set of rules. For teams still running legacy Hive Metastores, migrating to this centralized model is the required path for cross-cloud governance and auditing. Databricks recommends a two-step migration protocol to avoid hard cutovers and large-scale data movement. First, the legacy Hive Metastore is federated into Unity Catalog as a foreign catalog. This applies immediate governance, preparing tables for an in-place sync upgrade. In this modern model, centralized governance creates a stable core that supports decentralized compute resources without compromising security.